So yeah, my name is Vincent Guiteau. I'm working for the kernel working group of Linaro. And I'm involved on the scheduler and associated development. So during this session, my goal is to give a status on the latest evolution or latest feature which have been merged in the scheduler and which are the next, I would say, main topic, which are under discussion or which are studied for the scheduler. So yeah, don't hesitate to ask questions. I will start with a short status and statistics. So let me move to the first slide. Yeah, that's some statistics. I never did that before. So, and for this session, I decided to get some kind of statistic around the sked directory in the kernel to have an idea of what was going on and so on. So that give you on the left side the number of commits which are merged in the sked directory for the last couple of kernel release, and on the right side is the number of add and delete of line. So as you can see, we are around, most of the time, we are around between 25 and 50 patches which are merged. So I have put some, I would say, significant changes, but most of the time, the changes are really small, and even and we can have, so in some kernel version we can have a lot of small changes which make the number of commit going around 75, but usually we don't have that much rework. So yeah, I have put one which is on the kernel v3.3 where we have moved all the sked file in the dedicated directory. So that's why also on the code change I have removed that, because the diff was so huge that it was just hiding all the other changes for the release that happened after that. So yeah, the main changes which have generated a lot of commits. So it's mainly the rework of NUMA balancing, which is now which was in 3.13. So it's a bit old now. Also, when Ingo has rework all the header file of the scheduler and clean up this. And another big changes that have been the topology, the cleanup in the topology and the way to create them, and also when we have integrated the line grub. So grub, it's greedy reclamation. It's a feature of a news bandwidth. That's a feature of the line scheduler when you can use more than the bandwidth you have been committed to. And as you can see, the change is not that huge of a release. I mean, except from these few changes, usually it's not that change, even if you have several features which are matched. We usually tend to merge a small feature step by step instead of doing a big rework. So that was more for some kind of information about how the changes are going on the Linux scheduler. But so we have activity, but yeah, the change usually is not that huge. That might change for the next release, but usually, yeah, that we tend to be cautious before changing everything. So yeah, I will go through the new feature which have been merged. So since I have decided to start after the 5.4, which was the last LTS. So that gives us a few number of features which have been merged. So I have only focused on new feature, and I have skipped everything related to the fix, the improvement, or the optimization, because I mean, we have that all the time, and yeah, the list would have been quite long. So that's why. So all the features that I mentioned there are not the only things that have been merged, but are just new feature which could impact the way the scheduler is working. So on the 5.5, maybe one of the main changes was the rework of the load balance, which was going on for a while. So the goal was to clean up and clarify the way we were balancing the task between each CPU and between each node. So from a normal load balancer point of view. The change in itself is not that huge when you look at the number of lines which have been changed. And the main goal was mainly to not regress everything, which has been, I think, almost achieved. And that has also helped to clarify and simplify the way we were selecting the task to migrate on other sides. So following this, few other changes have been merged since 5.5. Another one, which was in the utilist, a way to ramp up faster the estimated utilization of a CPU, which then is directly used to select the frequency. And the goal was to speed up frequency boosts when new activity was going on or was increasing, which was given some performance improvement. And the last one was a new way to access the kernel CPU stat. So that's a way to get everything in once instead of accessing different field one by one. On the next kernel release, so we have more feature. Maybe one thing which is interesting is the RT capacity awareness, which have been merged in this. So until now, until before this version, only the CFS was aware of the capacity of different capacity in the system. And with this, starting from this kernel version, so even the RT tasks are placed on the CPU depending of its capacity. There were also other small, so the ES also was using the uclamp in order to select the CPU and not only selecting the frequency, which was a new feature that was enable a task to be put always on big core, for example, instead of just increasing the frequency. And also another feature which was interesting was about the scheduled task. The goal was really to make them easily and aggressively preemptible by CFS task. So the main goal of this is really to, I would say, to put some background task to use the spare cycle of a CPU, but to not disturb your main load on your system. So that can be either on a server, so you can use this spare cycle to do some transcoding or whatever you want, or even on a mobile, the goal might be to do some background activity. So, but I'm not sure that it's used yet on mobile side. Also, there was, yes, another feature which is related to the NUMA that allows small imbalance. Up to now, we were trying to be fully balanced between the node, but in some case, entering an even balance between the node is not really useful, especially when you have a lot of spare cycle on each node. That doesn't really impact your bandwidth or your throughput, and that's helped to share the data locality between the tasks. So that's why these have been introduced, and this is then used to improve this kind of imbalance. Up to which level we can allow an imbalance between two nodes. So that's something which is not yet fully, I would say, optimized. So right now it's quite conservative, but the goal is to improve this and maybe for the end goal will be to be able to keep several tasks on the same node to ensure throughput optimization. The last one has been a small improvement, and if I remember correctly, it was especially for XFS file system. And the goal is that when there is this use case where you are using a case thread, which in fact, so you have a main task that use a case that send an event, and then a case thread is woken up to acknowledge the content and wake up then the main task. And with this, so before this patch, we can see that there were ping pong between several CPU, because when the main task was waking up, the case thread was running on its previous CPU, which so we were selecting another one, and then the new case thread was used on this new CPU and so on. So now when a case thread wake up another task and is the only one running on the CPU, the task, the waking task stay on the same CPU. We make the assumption that the case thread will sleep close really soon, and it was just after waking up the CPU. So the goal is to improve the locality, the data locality. So this was for the 5.6. For the next one on 5.7, so yeah, the frequency invariance has been merged for the Intel platform. So it's already there. It was already there for ARM platform, which are using a CPU FREC DT driver, which is the one used by most of the embedded system. That also means that if you're using other CPU FREC driver like the CPPC on ARM platform, for example, you don't have the frequency invariance. But now there are some patches which are under discussion and review to enable that also for the ARM server. Also, among the change, so in the statistic, we have removed the runnable load average, which was created based on the load of a task and the fact that it was runnable by something much more simple, which was the runnable average. So it's only it's monitoring only how long you are ready to run, and that includes the running time, but also your waiting time. So this has simplified the metric, how we were computing the metric in the scheduler, and especially the hot pass. And this give a better, more stable value. So another interesting feature for the scheduler was the thermal pressure, where the thermal framework can give feedback about which part of the system is under pressure and, and have a reduced compute capacity. Also, yeah, something interesting for the embedded system is the support of dynamic for fast wake-up pass. Up to now, it was not fully handled because on dynamic system, ARM dynamic system, all the big and the little belong to the same last level of cache. Whereas the previous assumption for heterogeneous system was that each big and little were belonging to different last level of cache, and then the balancing was done at upper level. And then another thing that was interesting is the distributed task. So yeah, when some tasks are forking, they are looking for the first available CPU and the first idle CPU, but in some case, all the new forkly tasks were selecting the same CPU. So some change have been done to make sure that we'll use the next one after each and every changes. So and then so on the 5.8, yeah, there were few new feature which are mainly supporting the case where the load of a task is null, which can happen when you have some huge number of CPU or huge number or a deep C group topology, and also the way we're using the runnable average. But yeah, this one was required from a new feature point of view. There were a lot of fix and cleanup, but no real new feature. And then the 5.9, which I think we are quite close to the RC7 now. So we have the deadline. So the deadline will have the capacity awareness. It was the last scheduling class which was not capacity aware. And also there is a remove, that's an important thing also, of the set scheduler export. So the goal is to prevent some module to set their RT priority, because we consider that there is no way when you're selecting a RT priority, this must be done having in mind the other RT thread which are running with you, which is not really possible from a module. So these have been simplified, and there is only some by default there is some few value, and then it's up to the system admin to set that to the right value. Another interesting one is the uclamp, the support of a global RT boost value. So the goal is to be able to make sure that you will run at a value, at a CPU FREC value for RT task, and not only the max CPU frequency. And also something interesting, especially for server, is a better spread of the fork task. And this have been done especially for a system using OMP, for example, where you have a lot of tasks which are created, and the goal is to spread them directly at fork instead of waiting them to start to be used before balancing them. So these are the main features which have been merged. Then let's come to the new one, which are under discussion. So I have selected 6 of them, which different level, I would say, of readiness. So the first one is the fairness of the CFS. So this one, I would say, is quite close to completion. The patch is there. This has been tested and hacked by some people. So we had some problem of a fairness running time distribution on the scheduler, depending of the topology and the number of tasks. So we now have some patch which enable a better fairness distribution. And this can be useful, for example, especially when you are starting several threads and you're waiting for the last one to finish before moving to the next step. In such case, if the CPU get less running time than others, you will have to wait longer, and this can decrease your performance. Another one, which is a better collaboration between the NUMA and the normal balancer. So that's something several patches are going on the mailing list, and we're also working on that. So now that we have reached a level where the NUMA balancer and the normal load balancer have the same view of the load of the system, at least from a CPU load point of view and a CPU running time point of view. And the goal now is really to make sure that they are both looking in the same way when they are balancing the task. And probably the next main difficulties will be to make sure how to improve the throughput and how to, I would say, allow this imbalance from a load point of view in order to improve data locality and throughput. So that will be something. We have some people in Linaro who have started to look at that, and we'll continue working on this and see how we can improve the overall performance. So, but I know that several other people are working on this on Red Hat, on Intel side, and so on. So I expect more patch to be available on the mailing list soon, but that will be, I would say, probably one of the next main area of changes in the scheduler from a load balance point of view. I think, yeah, we'll speed up a bit. So then another feature which have been discussed and is still discussed for a while, that's the core scheduling feature. And the goal is mainly the first goal is to make sure that the task or the thread that will run on the same core CPU, on the same core, will trust each other in order to prevent some speculative attack and so on. So that's mainly for SMT-based system. And this is based on you set a cookie for each task which trusts each other, and the goal is to make sure that at each and any time on one core only thread that trust each other will run simultaneously. And if we can't find enough thread in this case, we will force one CPU to be idle on the core while the other one is running a thread. So this has a lot of impact in several areas. So on the load balance, on the task selection, especially because now by default the scheduler is a per CPU or per run queue mechanism, and in this case you must also include a per CPU. So you must look at several run queues simultaneously, or you must coordinate which tasks are running on each CPU, on all the CPU of a course simultaneously, which mean a lot of log to be used and so on. So this has an impact on the performance. And also, this is quite difficult to keep some kind of fairness between the CPU and the thread running on each CPU in a core because of this, because you have to compare. Normally we're using the vRun time to make a decision between which task must run first. And this vRun time is only per CPU, per run queue, sorry. So with this scheduling decision at core level, you have to compare the variant time between run queue, which is not something that is quite easy. And also on the load balance, you should also take into account the fact that some tasks should not be pulled on a run queue if I would say if some tasks without a cookie are there. Okay, you have only 5 minutes, if I'm not wrong. So the latency nice. Also, that's a new way to set. More and more people are complaining about the fact that you can't you can't say if a CFS task, is latency sensitive or not, and should be, I would say, promoted in the when we are selecting for the next task to be running on a CPU. So the goal would be to create a new kind of latency priority, similarly to what we have for the niceness of a CFS task. The discussion is going on for a while now, and we have the main problem that we have right now. So I think that now everybody agree between the use of a latency nice, which will be between minus 19 to 20. Minus 19 mean that you have some you're more sensible to latency, and minus 20 saying that you don't care about your scheduling latency. Now the discussion is mainly about what to do behind this kind of priority. And so there are 4 main behavior that people want to put below that. Some are sometimes, I would say, a bit at the opposite direction. So there is one which is mainly right now when a task wake up, and when we are looking at if we can preempt the current one, we are using some slice to make the decision. So one idea is to use this to shorten the slice time before, in order to be able to preempt a task with a higher latency nice value more easily, and at the opposite, to wait a bit if you have a high latency nice value. So this seems to be quite reasonable and in line with what that means. Then we have another behavior, which is mainly for embedded system, where you want to select for an idle CPU when you are latency nice sensitive. So the goal is really to run on that. You have a small system, usually 8 core, and you want to look for an idle CPU, if any. And I would say that at the opposite, on some large system, or you would like to not look at any other CPU, but just say, okay, remain on the same CPU, because you know that you will be scheduled really soon, and it will take more time to look for another CPU than just waiting for you to be scheduled. So I expect the discussion to move forward on this during the last couple of months, in order to reach a decision and an agreement. The next one is the proxy execution. That's also something that is going on for a while. And the main idea behind that is that instead of around a thread, you have an execution context. And the goal is that not only one thread, but several threads can use the same execution context to run. And typically, this is useful for, I think that from the beginning, it was for the deadline task, and especially when you are a deadline task and you take a mutex, but this one is already taken by a CFS task. In this case, you're blocked, and you have to wait the other one to run. But how do you really promote this? Because it's not only a priority, but you have to take into account this kind of bandwidth and so on. So the goal would be to, in this case, to make the normal CFS task running in the deadline execution context. So it will use the runtime bandwidth and so on. So that will be useful for that, and also maybe that can be useful for, in order to make some kind of to simplify the RT throttling stuff and even the CFS throttling stuff, because you can encapsulate that in a deadline execution context. So this one is not yet really mature, but I think that's something that is that would be quite useful for us. That will simplify a lot some priority inversion problem and so on. The last one, I've just added that because it's have a rise on the mailing list recently. That's about this migrate disable support for the RT kernel. So in order to have a full preempt RT kernel, there's some discussion to be able to disable the migrate of a task. And the main goal behind that is just to make sure that when a task is running, or when you are in some contexts, you don't want to be migrated until the end of this section, which can be critical. But this also some other part to be preemptible. I'm afraid that I'm going out of time. We are already 26. So I will stop now. Maybe I can take a few questions. I can continue if there is any question. I can continue on the Slack interface.
Okay. Yeah. Hold on. Someone raised hand.
Oh.
Oops.
Hi, I have a question about
the
new thing you mentioned, new spreading in 5.9. What happens exactly? Do you guarantee that if a thread does, if you have 100 cores and if you do 100 news, that they will all end up on different cores?
Yes, that's the goal. And yeah, that's really what we have tried to do. And normally that's what is happening.
So often I see that, I mean, it takes some time to do 100 news. And in those threads, when they do their news, maybe they just do a little bit of initialization and then they block for the other news to be done. And so then you have maybe 10 news that happen and then they all start blocking. And then the cores, those 10 cores are going to look like they're idle. So do you still keep moving them on to other cores, even though some of the close by cores seem to be idle?
Yeah, that's what we have fixed with this patch. That typically this problem. Yeah.
Okay, great, thanks.
Any other questions? I think we are 3 minutes over. But usually we have 5 minutes buffer. So if there, let's take last question if there is any. Okay, sounds no more questions. Thank you, Vincent. Thank you.
Thank you.